Hello everyone, myself Assistant Professor Vatsal Patel from Civil Engineering Department working at Mahatma Gandhi Institute of Technical Education and Research Center NAVSARI. Today we are going to discuss about tachymetric surveying and our today's topic is methods and fieldwork. So be ready with your pen and paper. So in tachometric surveying, instrument used is known as a tachometer. With the help of a tachometer observation, say STADIA readings and vertical angles are taken and horizontal and vertical distances are determined by using formula. Before doing calculation, we should know the values of two constants for a tachometer to be used for survey work. So generally their values are mentioned in the catalog supplied by the manufacturer and also it is determined by various measurement. So let's see it. So first of all let's see STADIA constants. So STADIA constant or tachometric constants are multiplying constant and additive constant. So first one is multiplying constant. So it is given by the equation A is equal to F upon I, where F is equal to focal length of the lens and I is equal to STADIA intercept. The value of multiplying constant is generally 100. Next is additive constant. So it is denoted by B and it is given by F plus D, where F is equal to focal length of the lens and small d is equal to horizontal distance between the instrument axis to optical center of a lens, and the value of additive constant varies from 0.15 to 0.60 meter. So STADIA constants may be determined by laboratory measurement and field measurement. So let's see laboratory measurement first. So the focal length of the lens f can be determined by means of an optical bench according to the equation 1 upon f is equal to 1 upon u plus 1 upon v. The STADIA interval I can be measured from the diaphragm with the help of vernier calipers. The distance d between the optical center and the vertical axis of tachometer can also be measured. Second method is field method. So you can see all arrangement here. Okay. So a fairly level ground is selected. Then a tachometer is set up at P1. At which point? This point. So the tachometer is set up at the P1 and pegs are fixed at Q1 and Q2 at known distance apart. Okay. So first we select the fairly level ground, then tachometer is set up at P1 and the pegs are fixed at Q1 and Q2. Next, the staff intercept or say STADIA readings are noted at each of the peg. Let this intercept be S1, this one and S2. Okay. So the horizontal distances of the pegs from P1 are accurately measured and let this distance be D1 and D2. So we are measuring distance from P1 and till Q1 it is D1 and till Q2 it is denoted by D2. So by substituting the values of D1 and D2, S1 and S2 in the general equation which is D is equal to A into S plus V. So we get the two equation like I have already mentioned all the steps here. Okay. So you can see it from here. So if we talk about the equation, so by substituting the values of D1 and D2, S1 and S2 in the general equation D is equal to AS into B, D is equal to A into S plus B, we get two equations as follow. D1 is equal to A into S1 plus B and D2 is equal to A into S2 plus B. So by solving the above two equation, values of A and B are determined. Next is analytical lens. So an additional convex lens is provided between the eyepiece and the object glass at a fixed distance from the object glass is known as an analytic lens. The object of providing the analytic lens in the telescope is to make the additive constant say F plus D exactly 0. Analytical lens is provided in the external focusing telescope and is not required in the internal focusing telescope. Next is advantages of an analytical lens. So as the additive constant say capital B is 0. The calculation of distances and height is very much simplified. Like d is equal to a into s plus b. If b is equal to 0, then d is equal to a into s. So if multiplying constant is 100, the distances are directly obtained by multiplying the staff intercept by 100. So be sure you remember this point, it is very important. Okay. Next is disadvantage. So disadvantages of analytical lens are: the analytical lens absorbs some of the incident light, which consequently result in the reduction of the brightness of the image. It also adds to the initial cost of the instrument because of one extra lens. Next is the subtense bar. So the subtense bar is an instrument used for measuring the horizontal distance between the instrument station and a station where the subtense bar is to be set up. And subtense method is an indirect method of distance determination. This method is essentially consists of measuring the angle subtended by two ends of a horizontal rod of fixed length called a subtense bar. So here you can see its image. So in this method, a staff or target rod is not necessary, and the theodolite required is also of the ordinary transit type. The subtense bar is a metal bar of length varying from 3 to 4 meter. There are two discs of diameter about 20 centimeter at both ends of the bar. The discs are painted black or red in front and white on the other side. So the LED is made perpendicular to the axis of the bar. A spirit level is included for leveling, and the bar is mounted on a tripod stand which contains a ball and socket arrangement for leveling. So you can see all the arrangement here in the image. Okay. Next, we are going to discuss about field work in tachometry. So the first one is suitability. So a tachometric survey is conducted mainly for preparing a contour map of a reservoir site, alignment of highways or railways and canal, etc. So it is also suitable for carrying out traverse and filling in detail in rough and rugged terrain where direct chaining is very difficult. So by means of a tachometer, the relative distances and RLs of different points can be computed from the instrument station by taking observation like vertical angles and staff readings. Next one is recognitions. So before starting the survey work, the area to be surveyed is truly inspected or say examined, and the instrument station are selected according to the nature of the area. So here you can see the image. So if the survey is conducted along a narrow belt, the stations are selected along the center line of the belt. For example, alignment of highways, railways, canal, etc. So you can see its arrangement in the image like A, B, C, D, E. Okay. So by this it can be done. So if the area is comparatively broad, it is to be enclosed by a closed tower, for example small reservoir site, etc. So then it will be like this image. Okay, closed towers. If the area is extensive, it is divided into number of well conditioned triangles or say triangulation. So you can see area is extensive, so we have used the triangulation method, and all the area is converted into some triangles, and by this the various procedure is done. So tachometric stations should be so selected that they should command a wide area and that the large vertical angles are avoided. Next, equipments are tachometers, STADIA rods or leveling staves, a tape, ranging rod with flags, pegs, hammers, compass, etc. Next is field party. So the field party consists of number 1, the surveyor who is in charge of the party and supervises whole survey work such as recognitions, selection and location of stations, positions of staffmen, selection of benchmark, etc. Second one, the observer who is taking the readings. Third one is the recorder who records the reading in traverse book or say tachometric book and assists the observer. Fourth, 3 or more staff men. Fifth, 2 or more X-men for clearing and fixing peg, etc. And the last one, 2 or more watermen for providing water to fill party. So this is the fieldwork in tachometry. It is important one. So be sure you remember each and every point. Next is reduction of reading. So after the fieldwork is completed, the distances and elevations of various points can be computed using the formula already given. Even though a theodolite might be fitted with an analytical lens, the reduction of distances by tachometric formula involves laborious computation. So, however, where a large number of observations are made, the process of computation becomes time consuming. So to avoid these computations and to achieve speed in reduction of readings, some methods of reduction are employed in practice. So this method involves the use of tachometric tables and reduction diagrams. So if we talk about reduction diagrams, a graphically constructed scale which is used to measure correction for horizontal distances and vertical components is known as reduction diagram. There are separate diagrams for the horizontal distances and vertical components. Various forms of reduction diagrams are available. And if we talk about tachometric tables are preferred for 1 meter staff intercept on the staff held vertically, and the tachometric constant are 100 and 0. Different forms of tachometric tables are available in market. Next is errors and precision. So the following are the different sources of errors in tachometry, like instrumental errors, personal error, and errors due to natural causes. So if we talk about instrumental errors due to imperfect adjustment of the tachometer, the adjustment of the tachometer may not be perfect. The errors will occur. The permanent adjustment of the tachometer should be checked and corrective action may be taken if necessary. Errors due to staff or say stadia rod, the graduation of the staff or stadia rod may not be uniform. Then the error will occur. The stadia rod should be standardized. Either the imperfect staff or rod should be replaced or necessary corrections should be applied. Errors due to instrument constant. If the multiplying constant say capital A and the additive constant capital B of the instrument may not be correct, the error will occur. So the constant should be verified by careful field observation before commencement of the work. Sorry. Next is personal errors. These are errors of manipulation and sighting. So errors due to inaccurate centering and leveling. To eliminate this error, the observer should ensure perfect centering and leveling of the instrument. Next, errors due to non-verticality of the staff. To eliminate these errors, the verticality of staff or say stadia rod should be ensured by means of a plumb bob or a circular bubble attached to the staff. The target, if provided on the stadia rod, should be accurately bisected. Next, errors due to incorrect estimation of the staff intercept, imperfect focusing of the telescope causes parallax and may lead to incorrect staff reading. The staff intercept should be accurately determined. Next, if the staff is not clearly visible, proper focusing should be done. The sight distance should be such that the graduation of the staff can be seen very distinctly. It is advisable to read all the 3 hairs and to check that the central hair reading is the mean of 2 stadia readings. Next, error due to incorrect reading of the vertical angle. The vertical angle should be taken very carefully. The value of the vertical component or say capital V depends mainly on the accuracy of the vertical angle. And the last one is errors due to natural causes. So if we talk about refraction, the errors due to refraction occur due to varying densities of different air strata because of temperature changes. To eliminate these errors, Surveying work should be carried out in the morning and evening hours during low temperature to avoid refraction. Next is sun. On a very hot day, the different parts of the tachometer may expand, affecting staff readings. To eliminate these errors, the instrument should be placed under the shade of a tree or protected by an umbrella. Also, avoid working in hot sun. Next is wind. During high winds, accurate work is not possible as the instrument does not remain stable. Moreover, it is difficult to hold the staff steady and vertical. To eliminate these errors, stop the survey work during strong winds. Next is poor visibility. Poor visibility is caused by a glare of strong light coming from the wrong direction or due to insufficient light. So, to eliminate such sources of error, the instrument should be so placed that the sun does not reflect from the object glass, and in case of poor visibility, stop the survey work when the visibility is poor. And if we talk about precision in tachometry, the permissible errors in tachometric surveying are detailed below. So first one, the error in a single horizontal distance should be within 1 in 500, and that in a single vertical distance should not exceed 0.1 meter. In an open towers, average error in horizontal distance may vary from 1 in 600 to 1 in 850. Next, in closed towers, the permissible error of closure in elevation may vary from 0.08 under root d to 0.25 under root d meter, where capital D is the distance in kilometers. In a closed towers, the permissible closing error should not exceed 0.055 under root p in meter, where p is the perimeter of the towers in meters. So here are some important questions which can be asked in your examination. So be sure you remember each and every theory because it is very important, and already we have discussed all these questions. Okay. So here I end my session. Thank you all of you.